This circuit simulates the operation of a rheostat lamp dimmer. When operated, the rheostat varies in the resistance from 0 to 25 ohms. This in turn varies the current to the lamp from 0.833 amps to 0.305 amps. This simulation demonstrates the total resistance measurement of series connected resistors. The resistors are joined end to end to form the series connection. The total resistance is equal to the sum of the individual resistive loads. In this case, 25 plus 50 plus 75 equals 150 ohms. The calculated total resistance value is verified by connecting the ohm meter into the open ends of the circuit and turning on the simulation and observing the display readings. This simulates the operation of a series voltage divider circuit. The resistors are joined in series and the circuit connected to a 9-volt source. Different voltage values are available for different parts of a circuit. The voltage drop across each resistor is directly proportional to its ohmic value. The higher the resistance value, the greater the voltage drop. The voltage drop formula is used to calculate each voltage drop value. In this case, 4.5 volts, 2.7 volts, and 1.8 volt respectively. The calculated voltage values are verified by connecting voltmeters across each resistor and observing the display readings. This demonstrates the total resistance measurements of resistors connected in parallel. The resistors are joined side by side to form the parallel connection. The total resistance is always less than that of the lowest resistance present in any branch. Total resistance values can be calculated using equations based on the resistance value and number of resistors used. In this case, 3 150 ohm resistors connected in parallel would have a total resistance of 50 ohms. A 60 ohm and a 40 ohm resistor in parallel would have a total resistance of 24 ohms. A 120 ohm, 60 ohm, and 40 ohm resistor in parallel would have a total resistance of 20 ohms. The calculated total resistance value is verified by connecting the ohm meter across the circuit, turning on the simulation, and observing the display readings. This circuit simulates the operation of a parallel current divider circuit. The 3 resistors form a parallel circuit bank that has a current of 10 amps flowing into it. The current flow through each resistor is inversely proportional to its ohmic value. The higher the resistance value, the lower the current flow. The current divider formula is used to calculate the current value through each resistor. In this case, 5 amps, 3.33 amps, and 1.67 amps respectively. The calculated current values are verified by connecting ammeters in series with each resistor and observing the display readings. This simulates the change in total resistance as additional loads are connected in parallel. As additional loads are connected in parallel, the total resistance of the circuit decreases. The total circuit resistance for each of the simulated operating conditions is calculated using the parallel resistor formula. In this case, the results are 50 ohms, 14.3 ohms, and 5.88 ohms respectively. This circuit simulates the total resistance measurement for resistors connected in a combination of series parallel circuit arrangement. The 30 and 60 ohm resistors are connected in parallel with each other and in series with the 40 ohm resistor. The resistance of the parallel pair is calculated first and added to that of the series resistor. In this case, the 20 ohms parallel resistance is added to the 40 ohms series resistance for a total circuit resistance of 60 ohms. The calculated total resistance value is verified by connecting the ohm meter to measure the total resistance and observing the display reading. This circuit demonstrates how resistance readings can be used to check a circuit for fault conditions. The normal total resistance of this series parallel circuit arrangement is 60 ohms. When R1 is simulated faulted, open, it is essentially removed from the circuit. As a result, the circuit will consist of R3 in series with R2 with a total resistance of 100 ohms. When R2 is simulated faulted, shorted, both R1 and R2 are shorted out of the circuit. As a result, the circuit will consist of only R3 and a total resistance of 40 ohms.